All right, these are the notes for homework 11, graphing polynomials. There are a few things to consider when graphing polynomial. Specifically, there are three things to consider. We want to find the y-intercept, which we do by setting x equal to 0. We want to find the x-intercepts, which there might be multiples of, by setting y equal to 0. And finally, or thirdly, we want to determine whether each x-intercept is going to bounce off the x-axis when we graph it, or we're going to go through the x-axis when we graph it. And I'll say after that, it's typically advantageous to make a sign chart of the function values. It's going to help us determine the bouncing or the going through, so we know whether or not the function is above or below the x-axis. And we'll do that in these next two examples. So, first example, we're going to graph f of x equal to x cubed plus 4x squared. And just as a point of interest here, whenever we're graphing a function, we're always going to include the y-intercept and the x-intercepts. So, to find the y-intercept, set x equal to 0. You're going to get f of 0 equal to 0 cubed plus 4 times 0 squared, which in this case is just 0. And these first few ones are going to have a lot of y-intercepts that are just 0, but we'll have some that aren't. To find the x-intercepts, we're going to set y equal to 0. Or if you prefer, you can say you're setting the function equal to 0. Kind of the same thing. So if we do that, we're going to have 0 equal to x cubed plus 4x squared. And the way we typically solve something like this is we factor as much as possible. So on the right-hand side, I'm going to factor out an x squared up to x plus 4. And then I'm going to set each of the factors equal to 0. So I'm either going to set x squared equal to 0 to get x equal to 0, or x plus 4 equal to 0 to get x equal to negative 4. Now, I should be a little bit more circumspect here. What I should really say is my x-intercept is an x value of 0 and a y value of 0, and this x-intercept is an x value of negative 4 and a y value of 0. This y-intercept was an x value of 0 and a y value of 0. And it's very much always the case that if the y-intercept is 0, one of the x-intercepts will also be 0. Has to happen. Okay. I don't always do this, but I'm going to these first couple times. I'm going to make a sign chart for my graph. So kind of just like we were doing with finding the domain of a function, I'm going to find all the zeros or all the x-intercepts and plot them on the number line. So my x-intercepts were 0 and negative 4. I'm going to look at the fully factored function. So I'm going to look at f of x here being x squared times x plus 4. I'm just going to figure out the sign in each of my intervals. So pick a number bigger than 0, like 1. 1 squared is positive, 1 plus 4 is positive. Positive times positive is positive. If I pick a number between 0 and negative 4, like negative 1, negative 1 squared is still positive, negative 1 plus 4 is positive, and then positive times positive is still positive. And finally, if I pick a number less than negative 4, like negative 5 squared is positive, but negative 5 plus 4 is negative, and a positive times negative is negative. Now, this isn't the domain question. We're not going to say we want all the positive parts. We're just going to say we know that our graph should be, well, in fact, I kind of like to draw. Our graph is going to do something like this. It's going to be negative here, and it's going to go through negative 4 and be positive there. It's going to touch 0, but it's going to bounce off and still be positive there. So that's kind of the idea of what our graph looks like. We know it should be positive above the x-axis, negative below the x-axis in certain parts. Cool. So let's graph it. So again, I'm going to draw my intercept. So I have an intercept at 0, 0, and an intercept at negative 4, 0. And then I'm just going to kind of do this. I know that my graph is negative over here, positive between these two, and positive after I have to hit there. I don't want to make it too pointy there. The graph should be smooth. It's going to be something like this. And I don't know how high up it actually goes. That's totally fine. Just make something that looks decent. You should have arrows at the end indicating that this keeps going up and to the right and this keeps going down to the left. Polynomials should always be smooth. There shouldn't be any kind of sharp turns or pointy points. So yeah, that's it. Oh, I would also point out this graph goes through at x at the point negative 4, 0. And we use a capital T for through in the homework assignment. And this graph bounces at 0, 0, which you can see from the graph. I would also point out that we're going to get going through when we change from negative to positive. We're going to get bouncing when we stay the same sign, either positive, positive, or negative, negative. Let's look at some more examples. Okay. The next example, we're going to graph f of x equal to x to the fifth plus 4x to the fourth minus 5x cubed. So, same deal. Find the y-intercept, set x equal to 0. We're going to get f of 0 equal to 0 plus 0 minus 0. Not very exciting. I don't think you need to show that work. You need to say it's 0. X-intercepts, we're going to set y equal to 0 or the function equal to 0, whatever you want to call it. And we're going to have 0 equal to x to the fifth plus 4x to the fourth minus 5x cubed. And just like last time, our job is to factor this as much as possible. I can factor out a common factor of x cubed. I'm left with x squared plus 4x minus 5. This quadratic factors further. It factors as x plus 5 times x minus 1. So it looks like I have three potential solutions here. I have x equal to 0. I should say I have three potential x-intercepts, which are solutions to this equation. X equal to negative 5 and x equal to positive 1. I should really write them as intercepts. So I should really say that this is 0, 0. This is negative 5, 0. This is positive 1, 0. My y-intercept over here also is 0, 0. Not exciting. So that's my y-intercept and my x-intercepts. Okay. Again, I'm going to make a sign chart. And this kind of glare over here, which is terrible. Sorry about that. That's that. I guess that fixes it a little bit. Sorry, I know it kind of looks kind of weird, but better than having the glare there. So I guess I could do this. That's slightly better, I suppose. Anyway, so apologies. To find the so I'm going to make the sign chart again. So on my sign chart, I'm going to have the x values 1, 0, negative 5. And I'm going to look at my fully factored form, x cubed times x plus 5 times x minus 1. Pick a number larger than 1, like 2. 2 cubed is positive. 2 plus 5 is positive. 2 minus 1 is positive. Product of positives is always positive. Pick a number between 0 and 1, like 1/2. 1/2 cubed is positive. 1/2 plus 5 is positive. 1/2 minus 1 is negative. So it's a negative times 2 positives. Pick a number like negative 2. Negative 2 cubed is negative. Negative 2 plus 5 is positive. Negative 2 minus 1 is negative. And the negative times the positive, negative is positive. Finally, pick a number like negative 6. Negative 6 cubed is also negative. Negative 6 plus 5 is negative. Negative 6 minus 1 is negative. And then negative times negative times negative is negative. We're about to make this easier, I promise. So what we're expecting here is our graph is going to be negative, and then positive, and then negative, and then positive. So it looks like every x-intercept is going to go through the x-axis. Great. So we can say that's a through, that's a through, that's a through. And then we're going to graph it. So our intercepts are at 0 and at 1. I should say our x-intercepts are at 0 and at 1 and at negative 5. Doesn't have to be perfectly to scale, like kind of going all the way out to negative 5 here seems a little annoying. It has to be negative and then positive and then negative and then positive. So something like this. Cool. Notably again, through, right? We go from below to above, above to below, below to above. So here's the thing you should start to notice is that for intercepts that come from factors that have odd powers like 1 or 3, we call that the multiplicity, the graph is going to go through the x-axis at that intercept. Whereas for graphs with intercepts that have even powers, or I should say intercepts that came from factors with even powers, like 0 came from x squared here with an even power, that's where you're going to bounce. So here, x to the second has this even power, x plus 4 to the first has an odd power. We bounced at 0 because 0 came from x squared. We went through at negative 4 because negative 4 came from x plus 4 to the first. So odd powers mean we're going to go through. Even powers mean we're going to bounce off. I'll say that again, and I'll still do the sign chart, but like it's good to know that that's what's going to happen. Okay, look, you got pests. Oh well. You keep this over here to keep the glare off. Sorry. No, the glare from this light here is not the best. All right, just got a few more examples. There's really not a lot more to it. So same deal here. Y-intercept, I think this is the last time. Oh, sorry, you can't quite see it. Apologies. So we're going to graph g of x equal to negative x cubed minus x cubed, negative x cubed plus 6x squared minus 9x. Sorry, you can't see that. One more time. Negative x cubed plus 6x squared minus 9x. Y-intercept very unexcitingly, again, we're going to set x equal to 0. G of 0 is going to be 0 plus 0 plus 0. So we get the 0 comma 0 y-intercept. X-intercept, usual deal. We set the whole thing equal to 0. It doesn't matter which side the 0 is on. I usually like to write it on the right-hand side. Factor out. And while I could factor out just an x, I'd rather factor out a negative x. I'm left with a positive x squared minus 6x plus 9. This factors further as x minus 3 times x minus 3, or x minus 3 squared. So it looks like I'm going to get either negative x equal to 0, which just gives me x equal to 0, which shouldn't be surprising because we already knew that 0, 0 was a y-intercept, so 0, 0 is also going to be an x-intercept. And here we get x minus 3 equal to 0, or x equal to 3, which means 3 comma 0 is going to be another x-intercept. Okay, before we do any sign chart or graphing, I'm going to point out x equal to 0 came from x to the first power. That's an odd power, so we know that at x equals 0, the graph is going to go through the x-axis. On the other hand, x equal to 3 came from the factor x minus 3 squared, which is raised to an even power. So at the x-intercept of positive 3, the graph is going to bounce off the x-axis. That's all we know. Now, I'm still going to make the sign chart to show you how that's working, but you don't really need the sign chart at this point. In fact, I'm going to make the sign chart after I graph it. Let me just show you my graph here. So I know I have x-intercepts of 3 and 0. There they are. It does, so I will point out, you do kind of need to know where you're starting off if you're above or below. So I point out that if I pick a number bigger than 3, like 4, negative 4 times 4 minus 3 squared is a negative times a positive, which is going to be negative. So over here, if I plugged in 4, I would get something negative. And then it's going to bounce off at 3 and then go through at 0. So it's going to look like this. Through at 0, bounce off at 3. And yeah, that point there is kind of not exactly where I meant for it to be. Oh well. Let's do the sign chart just to verify that that's really true. So if I pick a number larger than 3, like 4, negative 4 is negative, and 4 minus 3 squared is positive, and negative times positive is negative. Pick a number between 0 and 3, like 1, negative 1 is negative 1, and 1 minus 3 is negative, but the negative number squared is still positive. So you have a negative times a positive, which is still negative. And that's really why the whole bouncing thing happens, because whether you're on the bigger side of 3 or the less than side of 3, pick a number bigger than 3, 3 minus 3 is positive, positive number squared is positive. Pick a number smaller than 3, that number minus 3 is negative, but the negative number squared is still positive. So whatever side of 3 you're on, this part's not going to change signs. On the other hand, if we go to the other side of 0, and we pick like negative 2, negative 2 is positive 2. Negative 2 minus 3 is a negative number, squaring it, it's going to be positive. So you have a positive times a positive, which is positive. So since the 0 came from this factor that had an odd thing, an odd power, the inside changing from positive to negative actually affected the overall sign of the graph. So here we have a function that's above and then below and then stays below, bounces off. So we are through at 0, 0, and we are bouncing at 3, 0. It doesn't matter if you're bouncing below or bouncing above. A bounce is a bounce. Okay, 2 more graphs. Two more? I think 2 more. Finally, one. Oh, and by the way, here's the code for accessing the homework assignment number 11 before it becomes available to everybody. The code is TacoCat11. The T in taco and the C in cat are capitalized. So, looking at this next one, graph f of x. Oh, sorry, I'll keep that on screen. Graph f of x equal to x cubed plus 3x squared minus 4x minus 12. So y-intercept still as good as ever. We're going to set x equal to 0. we're going to get f of 0 equal to 0 plus 0 minus 12. So that's going to be negative 12, a different y value finally. So our y-intercept would be 0, comma, negative 12, right? The x-coordinate 0, the y-coordinate is negative 12. The x-intercepts, we're going to set the whole thing equal to 0. So we're going to set f of x equal to 0. So this is x cubed plus 3x squared minus 4x minus 12. That's our f of x. It's equal to 0. This one requires a special kind of factoring. It's called factoring by grouping. So from these first two pieces, I can factor out an x squared. I'm left with x squared times x plus 3. From these second two pieces, I could factor out a 4 and be left with negative x minus 3, but I'm going to make the smarter choice and factor out a negative 4. So the remaining piece is also x plus 3. These remaining factor pieces should be the same as each other for this to work. And then from each of these pieces, I can factor out an x plus 3. I'm left with x squared minus 4. And then x squared minus 4 does factor further. It factors as x minus 2 times x plus 2. So it looks like we have three x-intercepts. X equal to negative 3, x equal to positive 2, x equal to negative 2. So this would be the point negative 3, 0. This would be the point positive 2, 0. This would be the point negative 2, 0. I will point out, before I do the sign chart, although I am going to do the sign chart, each of these factors is raised to the first power, which is an odd number, which means each of these intercepts is going to go through the x-axis. I should say the graph is going to go through the x-axis at each of these x-intercepts. You can also look at the sign chart. So we look at our factored function here, x plus 3 times x plus 2 times x minus 2. Picking a number bigger than 2, like 5, positive, 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 the whole thing's positive. Between negative 2 and 2, pick 0. Well, we know we pick 0, we get negative 12, so it should be negative, but it's a positive times a positive times a negative, so it is negative. Pick negative 2.5. Negative 2.5 plus 3 is positive. Negative 2.5 plus 2 is negative. Negative 2.5 minus 2 is also negative, so it's a positive times a negative, which is positive. Finally, pick negative 5. Negative, 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 the whole thing is negative, because 3 negatives multiplied together is a negative. And look, just like I said, every time we get to an x-intercept, we're going to change signs, either from negative to positive or positive to negative, which means we're going to cross from below to above to below to above. So graphically, here's what this thing should look like. So I have, and I don't want to be, so here's where I wouldn't actually be super specific here. So I'm going to say that negative 3 is maybe about there. Negative 2 is there. I don't want to draw negative 1. And then positive 2 should be, I guess, about the same. So I know my graph is going to do this. It's going to go, it's going to start down here. It's going to go up and go through. It's going to hit my y-intercept. And then turn around and go back through here. And I don't actually know if it turns around there before my y-intercept or after. It doesn't actually really matter as far as we're concerned. Oh, sorry, that's 2, 0. Apologies. There's my whole graph. And again, each of these are a through, and a through. Cool. All right, last one. Again, the code for accessing the assignment before it's released is TacoCat11. The T in taco and the C in cat are capitalized. So here we're going to graph one that's already factored for us. X minus 2 cubed times x plus 1 squared. So the y-intercept actually is a bit more work than it usually is. So we're going to set x equal to 0. And we're going to get y equal to g of 0, which is 0 minus 2 cubed times 0 plus 1 squared, which is going to be negative 8 times 1, which is negative 8. So our y-intercept is 0, negative 8. X-intercepts, we're even in the better spot because we're going to set the function equal to 0, or y equal to 0, whichever way you want to think of it. Really, the y and the g of x are kind of interchangeable. So we're going to set x minus 2 cubed times x plus 1 squared equal to 0. And we're going to see that we're going to get x equal to 2. We're going to get x equal to negative 1. So here, our x-intercept is 2 comma 0. Here, our x-intercept is negative 1 comma 0. We should be able to say without doing any work that this at 2 comma 0, the graph is going to go through because we have an odd multiplicity or an odd power. At negative 1, the graph is going to bounce because we have an even multiplicity or an even power. Again, now we'll graph it first and then we'll do the sign chart and make sure that everything seems like it's good. So let's see, we can probably do this. I don't like to always make these little marks. We'll make them here. So there's negative 8. And then x is going to be, I'm going to make my x, oh, sorry. I'm going to make this not quite to scale. So that's 8 down, but I'm going to make my x-axis a little bit wider just to make it easier to draw things. So there's 2, there's negative 1. Okay, so fun fact, we know that at 2 it's going to go through and at negative 1 it's going to bounce. So when I go from here, it's going to have to go through there. When I go that way, it's going to have to bounce that way. So it should do something like this. This is actually one of the advantages of having a y-intercept that isn't the origin. Or you could have made the sign chart. The sign chart, which we just put the x-intercepts on, but not the y-intercept. Pick a number bigger than 2, like 3. Oh, I should draw the function or write the function. My function is x minus 2 cubed, x plus 1 squared. Pick a number bigger than 2, like 5. 5 minus 2 is positive. Positive number cubed is still positive. 5 plus 1 is positive. Positive number squared is still positive. Positive times positive is positive. Pick a number between negative 1 and 2, like 0. 0 minus 2 is a negative, and a negative number cubed is still negative. That's why the odd power here, the sign does change and the graph does go through. So 0 minus 2 cubed is going to be negative. 0 plus 1 squared is still positive, and negative times positive is negative. But now, let's look on the other side of negative 1. Plug in negative 2. Let's say negative 3. Negative 3 minus 2 is negative 5. Negative 5 cubed is still negative. It's negative 125. But negative 3 plus 1 is negative 2, but negative 2 squared is still positive. So this thing overall didn't change signs. You have a negative times a positive, which is still negative. So the even power here on the x plus 1 factor that gave us the negative 1 as our intercept means that the sign doesn't change from one side to the other of that intercept. So we're negative. In fact, we're negative, still negative, and then we are positive. Just like our graph here, negative below the x-axis. In fact, we can even say it right. We're negative down here. We're positive up here. So we're going negative until you get to negative 1, negative until you get to positive 2, positive afterwards. All right, that's pretty much graphing. Oh, there is, I guess, one more small thing to say that's not really about graphing, but just want to point out here. These are all functions, and the thing that makes a function is for each x value you plug in, you can only get out one y value. So for example, if I plug in x equal to 3 here, I can't get 2 different y values, right? G of 3, I will just point out, g of 3 is equal to 3 minus 2 cubed, which is 1 cubed, times 3 plus 1 squared, which is 1 times 4 squared, which is 16. Oh, sorry, you didn't see that. Apologies. G of 3 is 3 minus 2, which is 1 cubed, times 3 plus 1 squared, which is 1 times 16, which is 16. What I want to point out, though, is if I plug in 3 to this function, I can't get any other value out. What makes a function is that each input gives you only one output. So if I told you that I had the point, let's make it interesting. Let's say I knew I had the point 1 comma 4, which I do. If you, sorry, 1 comma negative 4, apologies. And I asked you the question, can g of 1 equal 5? The answer would be obviously no, because I know that when I plug in 1, I get negative 4. When I plug in 1, I can't get some different value also. All right, that's all there is to really say about graphing polynomials. After this, we'll talk about graphing rational functions, which is a polynomial divided by a polynomial. And that is all I have got.